everyone, let's take a look at number 20 here. It says a scientist is weighing each of 30 fish. She obtains a mean of 30 and a standard deviation of 2. So let me put that her mean was 30 grams and she had a standard deviation of 2 grams. All right, after completing the weighing, she finds that the scale was misaligned and always underreported every weight by 2 grams, i.e. a fish that really weighed 26 grams was reported to weigh 24 grams. What is the mean and standard deviation after correcting this error? Okay, so this is similar. I'm just going to reference. This is similar to number 10. It's not the exact problem, but it's similar to it. So I want you to imagine you had a data set where the mean was 30 and the standard deviation was 2. Now, I can't whip up a set that's got a magical standard deviation of 2, but let me try it this way. Let's say you only had 3 fish. I know she had 30, but let's say we had 3 fish that were at 28, 30, and 32. All right, and we found out all of those were underweighed. So really, and I'll put true data, should have been at 30, 32, and 34. So imagine everything just shifted down the x-axis by 2 units, right? Imagine you're on this x-axis. This is your variable fish weight, right? You're at 28, 30, and 32. Well, this needs to shift this way. This needs to shift this way. This needs to shift this way. So let me go ahead and say if this was your original 3 data points, and let me change the colors again, and you shifted them, they would just be down over here, right? And we'd have one at 34. So everything's just shifting 2 units down the x-axis. And in terms of how that would change your center and the spread, I hope you can see that since everything has shifted down, our center changes, right? If we think about the purple was centered at 30, but you can kind of feel that I guess these are like pinkish, right? They're centered at 32. So the mean does shift. It shifts. You can see it went from 30 to 32, right? And at that point, I can rule out A and B. But I hope you're also seeing that the spread between these numbers doesn't change, right? The distance between these data values does not change. You can see from here, right, from the mean down to 28, I lost 2 grams. From the mean up to 32, I added 2 grams. Same thing here. This was still a difference of -2 plus 2. Their spacing relative to each other did not change because when you add a constant to every data value in your data set, that doesn't change spread or standard deviation or variance. So what's going to happen is this is going to be answer C. The mean's going to change, but the standard deviation won't. And let's say you're not quite clear on all of that. You can plug these 2 data sets into a calculator and just test it. So let me go ahead and do that for a moment, right? You can see I put this one into data, or I put 28, 30, and 32 in there. Let me go ahead and define this to be L1 plus, we'll add 2, right? And what you can do here is you can run one var stats off of L1 and take a look that the mean is, I did get a standard deviation of 2. I should have checked this. Mean is 30, standard deviation is 2. So let's go write that out, right? So here, X bar was 30, standard deviation was 2. I'm only using 3 data points. I mean, she technically, this problem said she had 30, but I'll take it. So let's look at the new mean and standard deviation off of the data in L2. So let me go ahead and switch this over to L2, right? And then we've got 32 and 2. So let me write that out. So here we had 32 and 2. So again, you can see that the mean did increase by 2, right? And we'll go with blue, but the standard deviation stayed the same. That's why I'm going with answer C. So similar to number 10, if you get gut feelings about this, go with your gut. And if you don't have gut feelings, then make up some data sets that kind of help you through this process. All right. Thanks so much, everyone. Bye.